Good morning. Today we're talking about Sheetcam and using Sheetcam specifically for router operations. If you're familiar with using Sheetcam already, we're just going to be adding on to your knowledge. If this is your first time working with Sheetcam, I'd recommend watching other videos on Sheetcam so that you're more familiar with the overall concept of the system. Today we're going to be working with a small file here. I'm just going to go ahead and bring in a 4-inch file. So we're going to go File, New Part. We're going to just do this new part here, WM Test 1. Okay. Bringing it in inches and starting at the bottom left-hand corner. There are a lot of things that can be done with the router in Sheetcam. Now, it's not going to allow you to do the same level of three-dimensional work that you'd see in some of the more expensive software, like the Vectric Aspire software, things like that allow you to do unique three-dimensional figures. Beautiful stuff, just stuff that we don't do here. Now, before we get really into the process of cutting with a router on a right CNC table, because when it comes down to it, Mach 3 is going to run G-code. There's not a whole lot going on there. You just have to run G-code, and Mach 3 will run the same way that it always does when it comes to the system. We're not going to be doing anything special with the router setup, as this is a base plasma setup that uses router tooling. Alright, now the first thing we're going to do outside of bringing in our part is going to go to Options and Job Options. This allows us to determine the material thickness, the rapid clearance, and so forth. So here's where we'll do this. So let's say we're working with a sheet of half-inch MDF in this case. So what we're going to do is we're just going to say this is we're going to adjust that here, 12-inch by 12-inch piece of MDF. It's going to be a 1/2 inch, 0.5 inch, and we're going to set our rapid clearance. Rapid clearance is our point above the material that we're going to want our router to go once we zero it out to run our part. To move to the next part to start cutting. So I'm going to just set this at 1.25. So I want it to come off 1/4 of an inch off the material there while it's moving to the next part. We won't worry about these in this particular part of our system. So there we go. 0.25 off above the material when it's moving, and the material is 1/2 inch thick. And we hit OK. Now technically we can go like this and see, wow, and this I'm doing by holding the center part of my mouse, the scroll button down, so I can see what's going on. And then I double click to return it back to normal. Now there are two different types of operations that Sheetcam can do. One is called a pocketing operation. That is, it's going to form a pocket in the selected area. So it'll do the interior of this circle here, or it'll just do a pocket operation here. And that's how it'll run. Let's take a look here, and we can look at both of those tools. This is called Create a New Pocket Operation, and this is Create a New Contour Operation. Contours run around the edge of your DXF file. But before we start dealing with operations, we're going to need to set up our tooling for this. And Sheetcam allows you to run our tools here, create a new rotary tool. Now, if you don't see these tools here, all we have to do is go Option, Machine Options, and make sure you select rotary cutting. That allows us access to all of the other rotary cutting tools. So we'll select Create a New Rotary Cutting Tool. Rotary tool, we'll give it a name. In this case, it's going to be a 1/4 inch tool. 1/4 inch, we'll just call this a 1/4 inch tool in this case. We're not going to get overly technical. 1/4 inch bit for this case. And from here, we'll actually determine what the length of that bit is, what the flute length is, what the diameter is, what the depth per pass. So this is going to determine at every time it goes to cut. If you're saying I want it to cut 1/2 inch, how far is it going to go by default at that given speed? And you're going to have to experiment with this a little bit, do a little bit of research on feeds and speeds, because it will vastly depend on the speed of your spindle and the speed of your spindle, the number of flutes on the tool that you're using will help determine your actual depth per and your feed rate. And they have great tools out there. We're not going to go over those here, but you'll just look up feeds and speeds and it'll allow you to find exactly what you're going to need to set up this for every tool. We're not going to go over that here right now. So what I do, at least in this case, if I'm doing 1/2 inch MDF, I'm going to go at depth per pass. I'm going to do 1/16 of an inch passes, add an approximate feed rate of 100 inches per minute, and with a maximum plunge rate or speed of 20 inches per minute in terms of depth on the material. Ramp angle, we're not going to worry about that here. And spindle speed, because we're not running a water-cooled spindle on our system, we're not going to have any control over our spindle speed unless you have a potentiometer that's hooked up to your router input on something like a Porter cable. That'll allow you to differentiate the speed of your, slow or increase the speed of your router. So there's some, there's a lot of information I'm tossing at you here. Essentially, we're going to be working with a router. It's going to be a 0.25 diameter router. We're going to have a 0.75 flute length so that we know exactly how far we can dive into this material. And total tool offset is going to be 0 because we're not actually doing any tool offsets with this program. Okay, 1/4 inch bit, cool. We're just going to go with that. Now that I've created my 1/4 inch tool here, you'll see, there she is, look at that. All right, and I can see that right here. Now, what we can do is go ahead and put a contour operation. Let's go ahead and run that. If we're to do a contour operation, this is what it's going to look like. We're going to select our layer, just like with any plasma cut. We always have to know what layer we're working with. I'll select layer 0, and I'm going to select my tool, which will be the 1/4 inch bit. All of this will auto-populate. I just hit OK. And it now runs what looks like a 1/4 inch operation. It does the outside of the outside shape, and it's going to do a contour on the inside of the inside shape. Now, let's see. I want it to go to a cut depth of, let's say I tell it to do a cut depth over the depth of the material. So, yeah, 0.625. Okay, and then I hit OK. It's going to automatically light up in red telling me, hey, we can't cut this deep because the tool will actually hit the table. You'll see it's written there, tool will hit table. So we're going to go to a cut depth of, let's say, 0.495. That gives us a little under 1/16 of an inch of material at the very bottom of our cut. Oh, I'm sorry, far under 1/16 of 0.005 inches of material down at the bottom, so that when we are making these cuts, the parts won't kick up and end up launching loose pieces or chunks, whole chunks of this cut out of the table. This allows us to just pull up off the material and we're done. So 0.495, or actually in this case I'll just 0.490. Okay, that gives us a 0.01 of material. I like to have a little bit more holding on there because, of course, routers are powerful. So we're going to go ahead and hit OK. And, oh, nope, tool's not going to hit table. Nope, it's not going to hit the table. We're fine. That was from the other one. Okay, cool. Because now you can see my lettering here is white, telling me that, oh, okay, you're absolutely fine. And that's a contour operation. You'll see the yellow line just barely highlighted here. This is the inside of an inside operation, outside of the outside cut, and that is how you'd get that piece to pop out of the table. Now, let's say, for instance, we're gonna change this up. We're gonna go ahead and show you what a pocket operation looks like. I'm just gonna change this, and we're gonna delete this. Delete operation. We're gonna select create pocket, and we hit layer 0, spiral pocket. We hit OK. Now what you'll see, and I'm going to remove the fill here, you're going to see that there is a series of operations it's going to run in order to create a pocket, or essentially create a little hole to the depth that we just input, and it's going to make multiple cuts there. Awesome. Now I have it going to a cut depth of 1/8 of an inch. That's fantastic. It'll cut 1/8 of an inch down. Let's see if we can see what's going on. And we can actually see, if we look at this, that it is cutting, doing multiple passes at 1/16 of an inch to get us to that point. You'll also notice that it does climb and drop to our 0.25 that we spoke about earlier on our rapid clearance and our job options. So, go and bring this down here. You can also see that the interior of this circle is going to remain at height. Now here's where we get interesting with layers, and I'm going to break into this a little bit more. Here we go, delete operation. Let's say I wanted to cut the inside of this but the outside of this. Well, if I were to I'll need to tell it that I want to cut this on a separate layer. I want to go to my contour tool, say, hey look, I want this, move to layer, and we're just going to name this inside hole. Alright, cool, it's been moved to that layer. I can now go create a pocket operation, put it on the inside hole, and it's going to cut 1/8 of an inch deep. And again, I'm using that same tool, 1/4 inch bit, hit OK. And now it's going to do an inside operation there. And then if we were to go and say, you know what, now that I've done my inside operation, this is an order of operations here. We're going to do another one, a contour operation on layer 0. That's the outside layer here. And we want it to cut down to 0.49. We hit OK. And now we can see that it's going to give us a cut like this, 1/8 of an inch drop here and a full 1/2 inch drop there. And we can probably see that here if I were to go to my pointer tool and turn this up. Let's see what happens here. Fantastic. Look at that. Alright, so you see by looking at the side profile of this cut, we see that it does a complete outside operation. And then it does this internal operation here at 1/8 of an inch depth. Look at that. Okay, so now we know. That looks really good. Okay, now all we have to do is run our file, run post-processor. We can take this to a router table. And what we have for the 0 of the machine is the top of the material. And then it'll know from the top of the material it has enough material to go 1/2 inch down. So that's how we use Sheetcam to do routing operations. This is just one video. We're working on a full library of them. This is just sort of a real blunt view into getting all of this set. So take a look there and we can go from there. Thank you.